Hello students, in the last few classes we discussed basics of trigonometry. We defined trigonometric ratios, sine theta, cos theta, tan theta and their reciprocals. We also have seen how these ratios change as angle theta changes. Now let us discuss few properties of these trigonometric ratios and some trigonometric identities. Well, the first one that we are going to discuss is the following. Sine theta and tan theta are odd functions. We will discuss what it means. And cos theta is even function. Let's understand what it means. In mathematics, a function is said to be an odd function. Function simply means, if I write y is equal to f of x, function means dependence, that's what it means. When we write y as a function of x, what it means is y depends on x. Y changes when x changes. Here sine theta is ratio of sides. Ratio of sides depends on theta. When theta changes, sine theta changes. Similarly, cos theta and tan theta. So sine theta, cos theta and tan theta are functions of an angle inside a right angled triangle. So odd function here means what? If f of minus x, a function of minus x, is equal to negative of a function of x, then such functions are called odd functions. Then the function is called odd function. If a function of minus x is equal to a function of x, positive function of x, f of minus x is equal to minus f of x, then it is odd function. If f of minus x is equal to f of x, then the function is called even function. Okay, now let's try to understand why sine theta, cos theta are odd functions, how this is true in the case of sine theta and tan theta, and how this is true in the case of cos theta. Okay, so what do we mean by this in the case of sine theta and tan theta? Here f of minus x is equal to minus f of x means, in case of sine theta, sine of minus theta is equal to minus sine theta. Why and how? Let's understand. We will understand in a minute. Sine minus theta is equal to minus sine theta. Similarly, tan minus theta is equal to minus tan theta. That is why these are called odd functions. How sine minus theta is equal to minus sine theta, how tan minus theta is equal to minus tan theta, we will discuss in a minute. Now, cos minus theta is equal to plus cos theta. F of minus x is equal to f of x. So cos theta is an even function because cos minus theta is equal to cos theta. We will discuss how. So cos function of minus theta is equal to cos function of plus theta. That is why cosine function or cos function is an even function. Sine function and tan function are odd functions. We will see. To understand how sine and tan functions are odd functions and how cosine function is an even function, Let's look at a right angled triangle drawn inside a unit circle. First, let's draw x and y axis. Now draw a right angled triangle in first quadrant. One more right angled triangle in the fourth quadrant. Let's draw one more right angled triangle in the fourth quadrant. Now look at these two right angled triangles. An angle measured in the anti-clockwise direction. In the counter-clockwise direction, if you measure an angle, it is positive from x-axis. Angle measured in the counter-clockwise direction is positive, and angle measured in the clockwise direction is negative. So angle above x-axis is plus theta, angle below x-axis is minus theta. Look at these two right angled triangles. Let me call this point A, the other vertex of the right angled triangle B. Take below right angled triangle, this vertex is C. Now look at these two right angled triangles. These two right angled triangles share the horizontal side x. For the right angled triangle above x-axis, y is positive. For the right angled triangle below y-axis, below x-axis, y is negative. AB is equal to plus y. Look at the figure. AC is equal to minus y. Okay. Now look at sine theta and sine minus theta. Sine theta is equal to AB by OB. This is R. This side is also R. So it means sine theta is equal to plus y by R. Look at the figure. Sine theta is plus y by R. Look at sine minus theta below right angled triangle. Look at the right angled triangle below x-axis. Sine minus theta is equal to AC by OC. Opposite side of angle minus theta, y, AC divided by OC, hypotenuse. So sine minus theta, what are we getting? AC is equal to minus y. So sine minus theta is equal to minus y by r. Sine theta is equal to plus y by r. Sine minus theta is equal to minus y by r. So it means sine minus theta is equal to minus sine theta. That is why this is an odd function. F of minus x is equal to minus f of x. The function of minus x is equal to minus function of x. Or in this case, it's a function of minus theta. Sine function of minus theta is equal to minus sine function of theta. Let's look at it for cos theta also in the similar way. Look at cos theta. In the figure, cos theta is equal to adjacent side divided by hypotenuse. Adjacent side is OA. hypotenuse is OB. OA is positive. This is on positive x-axis. So OA is equal to plus x. Hypotenuse is equal to r. So cos theta is equal to x divided by r. Similarly, find cos minus theta. Cos minus theta is equal to OA divided by OC. Again, you are getting positive values in the fourth quadrant. This is fourth quadrant. In fourth quadrant, cos theta value is positive. Look, OA is positive. X, this is still plus x. So cos minus theta is x divided by r. X is positive for above right angled triangle, x is positive for below right angled triangle also. So cos theta is equal to x divided by r. Cos minus theta is also equal to x by r. So from these two, I can say that cos theta is an even function. Cos minus theta is equal to cos theta. Hence, this is an even function. So this satisfies the condition for even function. F of minus x is equal to f of x. Now coming to the third case. Third function, tan theta. Look at the figure. Tan theta is equal to y by x. But tan minus theta is equal to minus y by x. In the right angled triangle below x-axis, opposite side is negative. So minus y by x. So tan minus theta is equal to tan theta minus tan theta. Tan minus theta is equal to minus tan theta. So tan function of theta is an odd function. Sine function is an odd function. Tan function is also an odd function. So the reciprocals are also odd functions. Cos function, cosine function is an even function. So its reciprocal is also even function. X by r. Reciprocal is r by x. Now, one more property of these trigonometric functions is sine theta and cos theta the ratios of sides in a right angled triangle, trigonometric ratios sine theta and cos theta. They are also called periodic functions. This property of periodicity, we use it a lot of times in physics to study periodic motion. Sine theta and cos theta are called periodic functions. What do we mean by periodic functions? If the behavior of a function repeats at regular intervals, if the values of a function repeat at regular intervals of time, in this case theta, at regular intervals of theta, so sine theta, the behavior of sine theta repeats at regular intervals, the behavior of cos theta also repeats at regular intervals. After every one cycle, again it's the same story we discussed in the previous class. If you look at a unit circle, if you draw a unit circle, after every one cycle, again it comes to first quadrant. After 360 degrees is complete. In the first quadrant, again it is 360 degrees plus theta. Okay? 360 degrees plus 90 degrees, 360 degrees plus 180 degrees, 360 degrees plus 270 degrees, 360 degrees plus 360 degrees. 2 cycles complete. So for one cycle, 0 degrees to 360 degrees. That is the first cycle. The second cycle, 360 degrees to 720 degrees. Okay, 360 degrees plus 360 degrees. 2 cycles complete. Third cycle, 720 degrees to 720 plus 360, which is 1080, 1080. So like this, after every one cycle, you know what happens in the first cycle? We also have drawn graph. In the first cycle, in first quadrant, sine theta value increases from 0 to 1. We have seen this. In the second quadrant, sine theta value decreases from 1 to 0. And in the third quadrant, sine theta value decreases from 0 to -1. In the fourth quadrant, sine theta value increases from -1 to 0. This is from 0 degrees to 360 degrees. From 360 degrees to 720 degrees in the second cycle also, first quadrant, second quadrant, third, fourth, again the same thing repeats. So after 360 degrees, again you are in the first quadrant, sine theta value increases from 0 to 1, 1 to 0 decreases, 0 to -1 decreases, -1 to 0 increases. So this keeps repeating after every 360 degrees, because for every 360 degrees it completes one cycle. Since this keeps repeating after every 360 degrees, we would say 360 degrees is the period of sine function. Even for cosine function also same. Look at cosine function, cos function. Look at cos function. You know, as theta increases from 0 degrees to 90 degrees, cos theta decreases its value from 1 to 0. As theta increases from 90 degrees to 180 degrees, cos theta value decreases from 0 to -1. As theta increases from 180 degrees to 270 degrees, cos theta value increases from -1 to 0. And from 0 to 1. So after 360 degrees, the pattern repeats. So the period of cosine function is also 360 degrees, because after every 360 degrees it keeps repeating itself. If you look at the graphs also, let's draw the graph. Sine theta graph and cos theta graph. So I'll draw sine theta versus theta graph here and cos theta versus theta graph here. For 0 degrees, sine theta is 0. For 0 degrees, cos theta is equal to +1. We have seen this. The shape of sine theta graph comes like this. And the shape of cos theta graph let's also draw the shape of cos theta graph. So look here, cos theta decreases from +1 to 0. As theta changes from 0 degrees to 90 degrees. Look at the values of theta here. This is 90 degrees. or in radians it is pi by 2. You can write it in radians also. This is 90 degrees or pi by 2 radians. This is 180 degrees or pi radians. This is 270 degrees or 3 pi by 2 radians. 360 degrees or 2 pi radians. 2 pi. 3 pi by 2. This is pi. Or 180 degrees. Sin 180 degrees is equal to 0. Cos 180 degrees is equal to minus 1. Cos 180 degrees is equal to minus 1. So what happens for angle greater than 360 degrees? The graphs repeat. Okay. If you draw for angle greater than 360 degrees, if you draw sin theta graph, cos theta graph, in the second cycle, angle greater than 360 degrees means we are drawing the graphs in the second cycle. Extend the graph. So what is the shape that you are going to get? It's going to repeat. So from 0 to 2 pi, look at the graph. 0 to 360 degrees, look at sin theta graph. From 360 degrees to 720 degrees. This is 720 degrees or 4 pi. 4 into 180, 720. Second cycle. In the second cycle, you are getting the same behavior. Similarly, for cos theta also, you will get the same. For cos theta also, you will get the behavior same. So for every one cycle, this is how the graph is going to be. In every one cycle, the graph is repeating itself. The behavior of sin theta and cos theta are repeating. That is why we say period of the function sin theta is 360 degrees or 2 pi radians. Period of cos theta also is 360 degrees or 2 pi radians. Okay. Now moving ahead, let's derive some trigonometric identities. So the first few trigonometric identities that we are going to derive are sin square theta plus cos square theta is equal to 1. Secant square theta minus tan square theta is equal to 1. Cosecant square theta minus cot square theta is equal to 1. These are the three trigonometric identities that we are going to derive first. All these three follow from Pythagoras theorem. In a right angled triangle, you know, sum of squares of sides is equal to square of hypotenuse. That's what Pythagoras theorem says, right? Look at the horizontal side. Let me call this AC. Horizontal side is AC or X, base of the triangle. Vertical side of the triangle is Y. The hypotenuse is R. This angle, let's say, is theta. Now these three identities follow from the fact that x square plus y square is equal to r square. You know this Pythagoras theorem, sum of the squares of these two sides is equal to square of hypotenuse. AC square plus AB square is equal to BC square. X square plus y square is equal to r square. x square plus y square is equal to r square means x square plus y square divided by r square is equal to 1. Just rearrange the terms. Take r square to the left hand side, it comes into the denominator. On the right hand side it is 1. X square plus y square divided by r square is equal to 1. Split the two terms on the left hand side. You will have x square by r square plus y square by r square is equal to 1. Or this is x divided by r whole square plus y divided by r whole square is equal to 1. X divided by r, adjacent side divided by hypotenuse is cos theta. So this is cos theta whole square plus y divided by r. Opposite side of angle theta is y, hypotenuse is r. Opposite side divided by hypotenuse is sine theta. So cos theta whole square plus sine theta whole square is equal to 1. Cos theta whole square is written as cos square theta. Cos square theta simply means cos theta whole square. Sine theta whole square simply means sine square theta. So this equation says that sine theta whole square or sine square theta. Sine theta whole square is sine square theta. Cos theta whole square is cos square theta. So this equation can be simply written as sine square theta plus cos square theta is equal to 1. Similarly, the second and third identity also follow from same Pythagoras theorem. Now look at the second identity. Secant square theta minus tan square theta is equal to 1. This can be derived from Pythagoras theorem only. From the same equation we can write r square minus y square is equal to x square. Similarly, to derive the third identity, we can write r square minus x square is equal to y square. The same Pythagoras theorem equation. Okay, here we can write r square minus y square divided by x square is equal to 1. This can be written as r by, split the terms, r by x whole square on the left hand side. Splitting the terms will give you r by x whole square minus y by x whole square is equal to 1. Do the same thing here also. You will get r by y whole square minus x by y whole square is equal to 1. Taking y to the left hand side and splitting the left hand side terms will give you this. In the figure, r by x is secant theta, x by r is cos theta, its reciprocal r by x is secant theta. So you can write this as secant theta whole square or secant square theta. Similarly, y by x is tan theta, so y by x whole square is tan theta whole square or tan square theta. So secant square theta minus tan square theta is equal to 1. That's the second identity. The third identity, r by y. R by y. Y by r is what? Sin theta. R by y is its reciprocal. So cosecant theta. So cosec theta whole square or cosecant square theta minus y by x is what? Tan theta. X by y is its reciprocal. So cot theta. Cot theta whole square or cot square theta is equal to 1. Cosecant square theta minus cot square theta is equal to 1. So these are the three identities that we can derive. So very simple. All these three identities follow from Pythagoras theorem only. Next, let's